Okay, questions have been asked about for the top hat. Questions 49 and 50. So let's deal with 49 first. But before we do that, let's talk about alkoxy groups. So first of all, an alkoxy group has an OR group. And if I go and I look at the table here, the alkoxy groups are basically a low priority group. They're given the same priorities as an alkyl group or a bromo or chloro. So in other words, they really don't have any priority. They're just going to be treated as groups. So as substituent groups. So for instance, how do you name them? Well, if you have an oxygen attached to a methyl group, it's going to be a methoxy group. If you have an isopropyl group attached to an O group, this group is going to be an isopropoxy group. So in other words, it's just the alkyl group with the OXY suffix. But this entire group has no more standing than a methyl or an ethyl or a bromo, and we just simply alphabetize it based on an M or an I. So if we go and we look at problem number 49 here, then there's one other rule we have to keep in mind as we name basically what is an ether. And that is that if you look at this molecule, and I'm going to go ahead and cut and paste it into the just going to cut and paste it real quick into the PowerPoint slide. If you're looking at this, basically we're going to take this entire molecule as it is, and the first thing we have to do with this molecule is we have to decide, okay, what are the functional groups and who has the highest priority? Well, in this case, as I'm looking at this molecule, I'm seeing an ether or an alkoxy group which has no real priority, and I see a double bond that does, that's higher on the list. So if I go back to my list here, the double bond has a higher priority than the OR group. So therefore, the double bond is going to be our priority group. Now, when you have the alkoxy groups, when you have an ether, and an ether just has two carbons attached to an oxygen, or two carbon groups, when you look at an ether, the rule for the ethers is that the group with the most carbons is going to become the parent group, and the group with the smaller amount of carbons attached to the oxygen, that's going to become our substituent. So this group is going to be nothing more than a substituent onto this being the longest continuous carbon chain. So what kind of alkoxy group is this? This is going to be an isopropoxy group. So if we look at this, if we look at the chain then, because I'm just going to go ahead and treat this as if it was a methyl or an ethyl. As a matter of fact, let's name them. So here we have a methyl group. Here we have a bromo. So we're going to have a bromo-methyl isopropoxy alkene. So now it's really down to naming alkenes. So let's find the longest continuous carbon chain that contains the double bond, and it's this one. There's my longest continuous carbon chain. And so I'm going to number, well, first of all, there's 1, 2, 3, 4, 5 carbons. So this is going to be a pent, and then a number with an ENE, So, because it's an alkene, so now let's say, okay, what are we going to number? Are we going to number from top to, or from left to right, or from right to left? Let's go right to left because that's the end closest to double bond. So 1, 2, 3, 4, and then 5. So this is going to be a pent 1-ene because the double bond starts at carbon 1. And so now I'm just going to go ahead and alphabetize and get my list of substituents along with where they're attached. And I'm treating the isopropoxy as a methyl or a bromo. So it's going to be a 2-bromo, 4-isopropoxy, and then 5, whoop, you know what? I just made a mistake. I just showed you something wrong here. That methyl group isn't a substituent. That methyl group is part of the longest chain. So my name's done. I have a 2-bromo, 4-isopropoxy, pent 1-ene. Okay, so the isopropoxy is just treated like any other alkyl group. Why is this part named as the substituent and not the part on the right? Simply based on the total number of carbons. This has 3 carbons over here, and this has 5 carbons over here. So it would be 2-bromo, 4-isopropoxy, pent 1-ene, and that is which one? That's B, it looks like. Because it's a pent, so in other words, it has to be this entire carbon chain is my longest carbon chain. Okay, so we just have to kind of isolate this as its own substituent. Okay, question 50. What is the following, what's the correct name for this molecule? So again, this has a double bond and an ether in it. The ether is basically the alkoxy group. The alkoxy group is below in priority. Is below the double bond in priority, and so the double bond then gets priority. And so as it gets priority, then the double bond chain is going to be the parent name, and the group that's attached to the oxygen is going to be the substituent. So let me again copy this. We'll paste it into this. And in this case, what I will do is I will get rid of that and I'll just blow it up so we can see all 4 names. Okay, so if I'm looking at this as my molecule, again, looking at this, looking at the ether versus the double bond. The double bond has the higher priority. And so this ether is just going to be named as a substituent. Now looking at the oxygen, which side of the oxygen has less carbons, because that's going to become the substituent? Well, that means this entire group right here with its 2 carbons is going to be the substituent of the alkene. And so now this is going to be my longest continuous carbon chain that contains the double bond. So this is going to be my parent, and the OCH2 CH3 is what kind of alkoxy group? It's an ethyl group, so this is called an ethoxy. And I also have a methyl group down here that is a substituent. So this is going to be an ethoxy methyl, whatever the parent name is. Now, the longest continuous carbon chain is 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be an oct. Oct what? It's going to be an octene. Number from left to right. we number from the end closest to the first, or closest to the double bond. So that means we number 1, 2, 3, 4, 5, 6, 7, and 8. And so that means this is going to be an oct. Shrink this down a little bit. This is going to be an oct 3-ene. Okay? So that eliminates that answer. It also, that's the only one that eliminates. All right, so it's going to be an oct 3-ene. Now I have my methyl group and my ethoxy. So I'm going to go ahead and say this is a alphabetizing E versus down here this methyl group. So E versus M. I'm going to have a 5 ethoxy, 2 methyl, oct 3-ene. Okay. So looking at this, we've got a 5 ethoxy, so that eliminates this one because it says it's a 2 ethoxy. And so now I'm down to C and D, and of course with C and D, what I have is I have 5 ethoxy, 2 methyl, octene, but now I have the cis or trans stereochemistry. So now I have to go to the double bond and say, okay, for this double bond, the hydrogen is here. For this double bond, the hydrogen is here. How are the double bonds situated? They are situated trans. So this is trans 5 ethoxy 2 methyl oct 3-ene, which means the correct answer for this is C. Okay, so again, when you have an ether, look for the other functional groups, because if there's a double bond or a triple bond, it will outrank the ether, and so that means the ether is going to become an alkoxy substituent. The smallest number of carbons on the side of the oxygen, that is what then creates the substituent. And after that, you name this alkene just like it was a methyl or ethyl, except in this case it's an ethoxy.